Welcome to Chapter 6. In this chapter, we're going to be solving systems of linear equations. Now, today, 6.1, you don't have a homework assignment for 6.1. I know you can cheer now. And 6.1 will not be asked about on your final. However, there are questions about 6.1 on your next exam. So we're going to go over 6.1. You don't have a graded homework assignment, but there are some extra practice problems. Now, the reason it's not on your final is technically everything in this lesson is supposed to be a review. But I understand it's probably going to sound new to a lot of you, so that's why we're giving it its own lesson of review before we move into the actual 1050 lesson starting in 6.2. So let's start with our review. Let's review what a system of linear equations is. So a linear equation in two variables is an equation that looks like this. ax plus by equals c, where a, b, and c are constants or numbers, and at least one of a and b is non-zero. So basically we're talking about equations like 2x plus 5y equals 7. Equations that have two variables, an x and a y, and a bunch of numbers. Now, a 2 by 2 system of linear equations means two equations, two variables. That's what 2 by 2 means. So, if you look, we have an example right here. I have 1 and 2 equations, and each equation has two variables, an x and a y, an x and a y. Now, a couple other vocab words that we're going to talk about. Let's label these with colors. If the system has no solutions, we call that inconsistent. If it has at least one solution, we call that consistent. Now, if it has, where is it talking about? There we go. If it has a single solution, so one answer, we call that consistent independent. If it has infinite number of solutions, which we'll see an example of today, we call that consistent dependent. So those are the three vocab words that we're going to be labeling today as we go. If there's no solution, we say it's inconsistent. If there's a single solution, we say it's consistent independent. And if there's infinitely many solutions, we call that consistent dependent. Now, let's actually dive into starting to solve these. There are two main methods that you've learned in the past for solving these equations. We have substitution and elimination. Now, these two methods should be reviewed, like I said. If not, that's okay, but hopefully as we go through this, it rings some bells at least. So let's talk about what substitution is. In substitution, we solve one equation for one variable and then plug that answer into the other equation. And then solve. So let's start with our first step. We're going to solve one equation for one variable. So I can either solve this equation for x, or I could solve that equation for y, or I could solve this equation for x, or that equation for y. Any of those options work. I'm going to pick this second one, and I'm going to solve it for y. So I take negative 4x plus y equals negative 5. I'm going to solve this for my y variable. So there's my equation for y. Next step, I'm going to plug that answer in to the other equation. So now I move on to the other equation, and anywhere I see a y, I'm going to plug 4x minus 5 in for that y. This is the substitution part. So we're substituting that equation for y in for y. Now I can distribute this negative. So I get 2x minus 4x plus 5 equals 1. And I can solve this like any equation since 7th grade. 2x minus 4x is negative 2x minus 5. Negative 2x equals negative 4. Divide by negative 2, and I get x equals 2. So that is my first answer. I know that x is 2. Now, we're not done yet because we also need to know what y equals. So now we're going to take this x equals 2, plug it into any of the equations that I have so far. So I could plug x equals 2 in here and solve for y. I could plug x equals 2 into here and solve for y. Or I could plug x equals 2 into here and solve for y. Now, just because I can pick any one of them doesn't mean that one of them isn't going to be easier than the others. I notice if I pick this equation here, it's going to be really easy to plug in x and get a solution for y. So that's the one I'm going to pick. So I'm going to plug in the answer I got for x. Y equals 8 minus 5, which gives me y equals 3. So those are my answers. I got x equals 2 and y equals 3. Now, for systems of linear equations, we always write our answer as a coordinate point, x, comma, y. And let's talk about for a second why we write our answer as a coordinate point, why we write it as x, comma, y. If you take these two equations that we started with and you plot them in a graphing calculator, say Desmos, right here. I have my Desmos up. Here's my two equations right there. If you look at these two lines, you will notice that the point where they intersect is the point that we just found. So that's what we're doing when we're solving a system of linear equations. We're finding the point where those lines cross, the point that they have in common. And that's what's happening when we write out our answer. We're saying this is the point that these two equations have in common, the point that's the same between them. So, now that we've, one last thing that we should do before you're done is label this system. We see that this is a system that has a single solution. It has one point that they have in common. So we would say that this is a consistent independent system. Because that is what we call a single solution system, consistent independent. So now that we've gone over all our vocab words and we've practiced substitution, in the next video we'll do several different examples where we practice with elimination.